Hey, this is Mrs. Lord, and this is the video for section 2.1, the derivative and the tangent line. And what we're going to learn in this video is how to find the slope of a tangent line to a curve at a point, use the limit definition to find the derivative of a function, and understand the relationship between differentiability and continuity. So here we go, first slide. We've talked about this before. You've seen this formula ever since we switched into the calculus book. And this is how to find the slope of a secant line. Remember, what we're doing is we're finding our delta x is how far out we're going to go. So when we do that, we're finding 2 points on my 2 points here and here. And I'm finding the slope of the secant line. And then remember, we talked about this, what happens when this delta x gets smaller and smaller. And I'm going to show a slide of that. So this delta x is getting smaller and smaller. So what's happening is those 2 points are getting closer and closer together. And if this delta x actually approaches 0, which is what it's saying here, then you're going to have no distance between your original point and your new point. So that is going to be the slope of the tangent line. And we've talked about this before. We've done a couple of these. They were actually on your last test. We're just going to talk about them a little bit more thoroughly this time. So what we have is we have the definition of a tangent line with the slope m is saying that if we take the limit as delta x approaches 0, and this is just change of y over change of x, we get the slope. And if we say that delta x is approaching 0, then this slope is going to be the slope of the tangent line, not just the secant line. So we have we're going to do 2 types of these. One is when we're finding the slope of a tangent line of a graph at a specific point. So we're going to put in C, and then we're going to have f of C, or the y value at C. And then we're going to find formulas to find the derivative or tangent line of the slope of the tangent line. All right, so find the slope of a graph of f of x. And f of x is equal to 3x minus 7. And we want to do at the point 4, 2. That's a typo. It should be 4, 5. Because if I put 4 into this equation, it would be 12 minus 7, which is 5. So make that correction on your note sheets now, if I haven't done that already. Okay, so here we go. We're going back, and we're going to use this formula here, which is, whoopsie, way too far, which is going to be the f of c plus delta x minus f of c all over delta x, and we're taking the limit as delta x approaches 0. So when I go ahead and do this, my c in this case is going to be 4. So c is going to be 4. F of c is the y value at 4. So f of 4 is 5. Just in case you didn't know that, I wrote that over there. So I'm going to take in the limit as delta x approaches 0. I'm going to write that every single time. And I'm going to say 3, and in place of c, I'm going to write 4 plus delta x minus 7 minus f of c. Well, f of c we just said was 5 all over delta x. Boy, that's really messy, and I'm sorry about that. All right, so now I'm still taking the limit as delta x approaches 0. This will be 12, I'm distributing the 3, plus 3 delta x. And while I'm here, I'm going to take negative 7 minus 5, and that's going to be minus 12. And this is all over delta x. Combining my like terms on the numerator, I have a positive 12 plus a negative 12. So those two will just cancel. And so I'm left with 3 delta x over delta x. I'm still taking the limit as delta x approaches 0. I can't substitute that 0 in right now because I'd have division by 0, and you can't do that. But these delta x's will simplify, and I'm going over here. I'm going to say the limit as delta x approaches 0, and it's just 3. Well, there's no delta x left. There's no place for me to substitute in 0 for delta x, so my final answer is just going to be 3. So what that means is the slope of the tangent line, slope of the tangent line at 4, because that's my point, is 3. Well, if you take a moment and walk away from the problem for a second, that should make sense to you, because if this is the linear equation, the slope of the line is always going to be 3, right? So the slope at every point is going to be 3. But that just works for linear, but I just wanted to point that out so you could see that. So moving on to the next one. We want to find the slope of the tangent line of the graphs at these 2 points, 0, 4, and 2, 8. So I'm going to stick with the same formula that I just used, and I'm going to do f of c plus delta x. So I'm going to take the limit as delta x approaches 0, and I'm going to do f of c plus delta x minus f of c all over delta x. So I'm doing this problem 2 times. This time was 0, so that's going to be my c. And then my f of c is going to be 4, because that's what I get when I substitute 0 in. So now I'm going to take the limit as delta x approaches 0. Putting in 0 here, this will be 0 plus delta x squared plus 4 minus f of c, which in this case f of c is 4. And this is all over delta x. Now, the downside to doing it this way is I'm only finding the slope of the tangent line at one specific point. In this case, I'm finding it at 0. We're going to go through a different way that'll give me a formula that I can substitute in for every point later on. This one, when I take 0 plus delta x, that would just be delta x. Delta x squared is delta x squared. And then the plus 4 minus 4, those will equal 0. So I'm left with delta x squared over delta x. I can simplify, so limit as delta x approaches 0, and I'm just going to be left with delta x because they would simplify. Now I substitute 0 for delta x, which now I can, and so I'm going to get an answer of 0. So the slope of the tangent line at x is equal to 0 is 0. Okay, let's do this point, 2, 8. I'm going to try and switch colors for you. So I'm going to do the same thing just to clarify. This is my c. F of c is going to equal 8. So when I substitute into this formula, I'm going to take the limit of delta x approaches 0, and then I'm going to have 2 plus delta x squared plus 4 minus f of c, which we just said was 8, all over delta x. So I'm taking the limit as delta x approaches 0. This, when I FOIL this, will be 4 plus 4x delta x plus delta x squared. And then this here will be minus 4 all over delta x. Then when I combine my like terms, the 4 and the negative 4 will equal 0. Everything that's left should have a delta x that factors out. If it doesn't, that becomes a special case, and we'll talk about that in a little bit. So I'm factoring out the delta x. I'm going to have 4x plus delta x, and this is all over delta x. Now my delta x's will simplify, which means I can go ahead and substitute in 0 for delta x with what's left. So I'm going to have 4x plus 0, and I'm going to be left with 4x. And then to find my slope, oh, I shouldn't have an x in there. Oh, son of a gun. Mrs. Ward, you shouldn't have an x in there because there is no x here. Oh, that's so annoying. So that x is gone. That x is gone, this x is gone, and my slope is just 4. I hope somebody caught that mistake before I did. All right, so there my slope would be 4. Moving on to the next one. So this next slide talks about a tangent line. So remember how back here I said usually you can factor out the delta x and then they simplify? Well, sometimes you can't, and what happens if you can't is you end up with what's called a vertical tangent line. So even though the function's continuous, see, this is a continuous function, at this point right here, my limit is going to approach either positive infinity or negative infinity at that point. So I'm going to have a vertical tangent line. So if it's approached positive infinity or negative infinity, you have a vertical tangent line, which means you cannot find the slope of that tangent line because it would be undefined. So moving on to the next one. Now we're going to do the formula for the, so this is the definition of a derivative using the limit formula. So it's just like what we just did before, except for I'm not doing it specifically for one point. Remember before we had f of c here and we had f of c, we were just doing it at that point c. By keeping the x in, we're finding a formula which gives us an equation to find the slope of the tangent line at any single point. So this is called the derivative of a function, and there's different ways that we can write, when we're finding a derivative, we can write it as f prime x, the change in y with respect to the change of x, dy dx, y prime, which is also derivative, then this is the derivative of x in terms of f of x, and then dxy. Those are all the different notations for a derivative. So when we do this, we're saying the derivative of y with respect to x. That means the change in y with respect to x. That means the instantaneous change in y with respect to x. I mean, I can say it a million different ways, but that's what a derivative means. It's basically you're finding the slope of a tangent line, and the slope of the tangent line will change throughout the function. So you're finding a formula to find the slope of the tangent line at a given point. So let's do one. So here I have one that's 3x squared minus 5x. Now we've done these before. You didn't really know what you were doing, but you were doing it right. So let's continue to do it right. So I'm taking the limit as delta x approaches 0 of f of x plus delta x. And if you don't like that delta x and you want to write h, you can. I'm not going to, but you can. So here I go. I'm going to do 3, and in place of x, I'm writing x plus delta x squared minus 5. In place of x, I'm writing x plus delta x. And then I'm going to subtract the function, which is what I started off with, making sure that I put in parentheses so I can distribute that negative sign. And this is going to go all over delta x. Now, I'm going to write the limit as delta x approaches 0 because I don't want to forget that step. That's a crucial step that's changing it from a secant line, slope of a secant line, to the slope of a tangent line. So that is a pretty important step. So I want to keep on writing it so I don't forget about that. Here, when I FOIL this and distribute the 3, I'm going to get 3x squared plus 6x delta x plus 3 delta x squared. Distributing that negative 5, minus 5x, minus 5 delta x. Distributing this negative sign, I'm going to have minus 3x squared, and then plus 5x. This is going to all be over delta x. Then I'm going to simplify what can be simplified, and so the 3x squares will equal 0. The 5x's will equal 0. Remember we talked about this before. Everything behind that minus sign should cross out with something up here. So it should equal 0, which means that everything is left should have a delta x in it. If it does not have a delta x in it, chances are it's going to be one of those special circumstances where you may have like a vertical tangent line. But we're good here, so I'm going to factor out the delta x. So I'm still taking the limit as delta x approaches 0. Factoring out the delta x, I'm going to have 6x plus 3 delta x minus 5, and this is all over delta x. Now that I made that delta x a factor, it can simplify. And now that it's simplified, it's okay for me to put 0 in for this delta x, so I'm going to do that as well. So now when I take the limit as delta x approaches 0, I'm going to have 6x plus 3. In place of that delta x, I'm writing 0 minus 5. So I'm left with 6x minus 5, and that is my derivative. So I'm going to write the derivative notation, and that's my formula for the derivative. So if I wanted to find the derivative at a point, let's say I had a point on this graph of like 1, I think -2 would be the point, right? That would be 3 minus 5, yeah. So if I wanted to find the slope at 1, I would just say the slope at 1 is equal to 6 times 1 minus 5. So the slope would be 1. So again, I just made that up on the fly. That's not on your note sheet. I just made it up. Just show you how we were going to do that. Are you kidding me? Oh, no, we're not kidding you. Sorry about that. I thought I forgot to push the record button, but I did, so we're good. So here we go. We're trying to find the derivative when f of x is equal to x squared, and then I want to find the slope of the graph of the function at the points 1, 1, and 4, 16. So since I'm finding the slope at 2 different points, I'm going to use that general formula to find the slope. So I'm going to do the limit as delta x approaches 0, and then x plus delta x squared minus f of x, which is just x squared, all over delta x. I'm going to simplify this, so still taking the limit as delta x approaches 0. When I FOIL this, I get x squared plus 2x delta x minus x squared all over delta x. Here I can see that the x squareds will equal 0. And I can also see that the delta x's will simplify here. So what I'm left with is the limit okay, then when I FOIL, I'm going to have the limit as delta x approaches 0 of x squared plus 2x delta x plus delta x squared minus x squared all over delta x. Here I can see that the x squareds will equal 0. What I'm left with is two things that have two terms that have delta x in there. So I'm going to say the limit of delta x as delta x approaches 0. Factoring out the delta x, I'm going to have delta x times the quantity of 2x plus delta x all over delta x. Here I can see that the delta x's will cross out and simplify. So now I'm left with the limit of delta x as delta x approaches 0 of 2x plus, and then in place of delta x, I write 0. So I'm going to be left with 2x, which means my derivative at a point x is going to be 2 times x. So going up here, when I want to find the derivative at 1, I'm going to put 1 in for x, and my slope at the point 1, 1 is going to be 2. When I want to find my slope at 4, I'm substituting 4 in for x, and I'm going to get a slope of 8, which is going to be a much steeper slope. All right, moving on to the next one. Find the derivative of the function. Same process. It's just going to be the same process, but you're just going to, it's different work. That's all. And so here, I'm still going to do the limit as delta x approaches 0, same process, and place it, well, I'm going to say delta t actually, because it is a t. So I'm going to have 2 over t plus delta t minus 2 over t, and this is all over delta t. Same process that we did before, but now we have fractions, and it's okay because we like fractions. So what we're going to do is to have a common denominator. I'm going to multiply this fraction by t over t. I'm going to multiply this fraction by t plus delta t over t plus delta t. When I do the first one, I'm still taking the limit as delta t approaches 0. Distributing my 2, I'm going to have 2t. Distributing this negative 2, I'm going to have minus 2t minus 2 delta t. This is all over my common denominator, which is t times t plus delta t. And this is all over delta t. Well, just refreshing your memory, this over delta t is understood to be over 1, right? So now I have this fraction divided by this fraction. So I can take this fraction and multiply it by the reciprocal, which would be 1 over delta t. And that's what I'm going to do. So what I notice here is that the 2t and minus 2t is equal to 0. So I'm left with negative 2 delta t over t plus delta t, and I'm multiplying by 1 over delta t. And I forgot to write, would never forget to write, limit as delta t approaches 0. Now I can see that these delta t's will simplify, and I'm left with substituting in the 0, because now I can substitute in the 0. I am going to have negative 2 over t times t plus 0. So I'm going to end up with negative 2 over t squared. And that's my derivative. And notice up here they had y is equal to. So when I go down here to write my answer, and I'm going to do y prime, which means the derivative. So that's the derivative. I don't think they wanted me to find it at a point. They didn't. So I am done with that question. So it's just the same formula, same process, just a little bit of different work, but thank goodness we have good algebra skills. That's no problem for us. Okay, the next one's just saying that if you have, if you're trying to find the limit and you can't find the limit, so you decide to do like a left bound and a right bound, and they are not equal to the same number, then you don't have a derivative either. So we can do a case that comes in, that's important when I look at an absolute value function. So I'm just going to sort of talk you through this for a second. Remember, this limit, this whole thing is actually asking me to find the slope, right? And since it's a 3, I'm trying to find the slope at 3. Everyone with me? Okay, so if I were to graph this, I know it's an absolute value, and at negative 3, whoopsie. Right, it's negative 3. Oh, you know what? My note sheet and your note sheet are different. You have x minus 3. Okay, so sorry. I think on the note sheet you have x minus 3. Let's go with x minus 3, because that's what you have on the note sheet, and then this would be negative 3, and this would be negative 3. So you're going to have something that looks like this. Absolute values, and that's actually at 3. If I asked you to find the slope as you're approaching this point from the left, you would say that slope was negative 1. If I asked you to find the slope as you're approaching from the right, so you're coming this direction, you would say, well, going from here to here, my slope is a positive 1. So since my slopes are not equal to the same number, I do not have a derivative. So the derivative does not exist. So we'll just say like this, does not exist. And the reason it doesn't exist is this is called a sharp turn. So when I have a sharp turn, that means I have one slope from one side, a different slope from the other side. So it's kind of like not having the same limit. So I'm not going to have a derivative at that point. So that's a sharp turn. And the next one, when we do one like this, where we have the function of x is equal to 1/4 power, if I were to do this, and they're asking me to find the derivative at a point. So this is going back to what we did before, find the derivative at a point. This would be x to the 1/4 minus f of 0, which is 0, and this is all over x minus 0. So I'm going to end up with x to the 1/4 over x, and that's equal to x to the 3/4, well, 1 over x to the 3/4. So if I try and put the 0, and this is one of those cases where the x doesn't simplify, so I'd have 1 over 0 to the 3/4, which you know is not possible. Undefined, can't happen. So what's going to happen here is if I were to sketch the graph, what this means is that I'm going to have a vertical tangent line. And if I have a vertical tangent line, that means that I cannot find the derivative. So that's one thing that you have to kind of understand, is that it is possible for a function to be, if a function has a derivative, then the function is continuous. So if I can find the derivative, I know the function has to be continuous. But it is possible where the function is continuous and I can't find the derivative. One example would be an absolute value. At this point here, you cannot find the derivative. Any other point, you're good to go. At that point where that vertex is, you cannot find the derivative. Another time you can't find a derivative is if you have a curve that does something like this, where at a certain point you have a vertical tangent line. So you can't find the derivative at those points either. But if you can find the derivative, then your function will always be continuous. So I hope this helps. I know I talked really fast. You have the classwork problems that are there. You will also have a drill. So best of luck to you. If you have any questions, email me and I will talk to you later. Bye.